Hey y'all, it's Becca. I'm a math, physics, and astronomy tutor here at Chegg. If you need such a tutor, feel free to hit me up below. This is a link to my profile. But today I'm going to talk to y'all about trigonometry, or a little piece of trigonometry. You may have heard of SOHCAHTOA in your studies. That helps us remember the functions sine, cosine, and tangent. And those functions help us solve a variety of different problems, but down to the basics, they can help us solve right triangles, help us find the side lengths of the legs of the triangle as well as the angles inside of the triangle. So we're going to do that today. So consider this right triangle right here. It has sides of length x, y, and z, and there's an angle theta right here. So the way we'd find the sine of that angle is we would use our SO. The SO stands for sine is opposite over the hypotenuse. So the opposite side divided by the hypotenuse. Now the opposite to this angle is the y side. And the hypotenuse is going to be this slanted side here, that z side. Okay, so we could find the sine of that angle by finding the fraction y divided by z. Okay, now the cosine is our ca. So the cosine is the adjacent divided by the hypotenuse. And the adjacent side, adjacent really just means next to, divided by the hypotenuse. So the adjacent side would be this x side here, right next to the angle. And the hypotenuse, of course, is z. Now the tangent of theta is going to be the sine of theta divided by the cosine of theta. Or, if you don't want to think about that directly, you can find the tangent by dividing the opposite by the adjacent, which ends up being the same thing. So we have our opposite side, which we already know to be y, and our adjacent side, which we already know to be x. So the tangent of this angle is given by y over x. Well, that's great. But we can expand this idea and we can actually solve a triangle with a given side length and a given angle. So we're meant to solve the triangle, which means we have to find the other two sides, this y and x side, and we have to find this other unknown angle right here. So there are several ways that you could do this. But first of all, let's just use our SOHCAHTOA functions, our sine, cosine, and tangent functions. So the sine of this 32-degree angle here, we know from the previous page that the sine of 32 degrees is going to be equal to the opposite side, which is y, divided by the hypotenuse, which we know to be 5. Solving for y, if we want y by itself, we know that y is equal to, all we'd have to do is multiply both sides by 5. So y is going to be 5 times the sine of 32 degrees. Now, when you're doing these calculations in your calculator, make sure that you are properly in degrees if your angles are given in degrees and radians if your angles are given in radians. Otherwise, you're going to get something a little bit silly. So 5 times the sine of 32 degrees is roughly 2.4, or rather 2.65 units. So we know that this y is about equal to 2.65. Okay? Now we could use the Pythagorean Theorem to figure out the other side length, because we know that x squared plus y squared equals 5 squared in this case. But we can also use our trig functions. We can use our cosine function. So we know that the cosine of 32 is equal to the adjacent, or the x side, divided by the hypotenuse, which is 5. So solving for x, we know that x is equal to 5 times the cosine of 32 degrees. Again, make sure that you're in degrees in your calculator. And that gives us about 4.24 for x. As a sanity check, if you wish, you can do the Pythagorean Theorem calculation, you can check that 4.24 squared plus 2.65 squared is equal to 5 squared, or 25. And you will find that indeed it is. And so that's a great sanity check if you wish. Now the final thing we have to do is we have to find this angle right here, this theta. There are a lot of different ways to do this. The most simple way is to recognize that there are 180 total degrees in a triangle. And we know that this 90-degree angle takes up 90 degrees of that. And this 32-degree angle takes up 32 degrees in that. So the only angle left over from that 180 total degrees is a 58-degree angle, which must be this one. However, you can use trig to find that angle. And since we haven't used it yet, let's do the tangent function. So we know that the tangent of this angle, we don't know what that angle is, but we know that the tangent is the opposite over the adjacent. That's our TOA in our SOHCAHTOA. So the opposite side to this angle, instead of being y, the opposite is actually x with respect to that angle. So we know that our x is 4.24. And the adjacent to this angle is our y side, our 2.65. So to get that angle by itself, all we would need to do is take the inverse tangent or the arctangent, depending on what you've learned, of both sides. And when we do that, that tangent function goes away from the theta, and we have the inverse tangent of 4.24 over 2.65 is our angle, and that should equal 58 degrees as well. So this is a brief intro on how to use trigonometric functions to solve right triangles. If you need any help with this, feel free to hit me up or any other trig tutor here on Chegg.